Ever wonder how accurate our machine learning algorithms are at interpreting subsurface channels? I'm going to show you an example of a study we did in just about 2 minutes. So we tackled this question using synthetic seismic data that was derived from actual outcrop data measurements in Chile. We used a handful of seismic attributes and tested two popular unsupervised machine learning methods, self-organizing maps and generative topographic mapping, to see how well they could identify the different channel facies in this synthetic deepwater system. What we found was kind of cool. While both methods performed similarly, they struggled with identifying individual channel facies, especially in cases where we had imbalanced data distributions. We also found that the GTM method showed slightly better performance in distinguishing between channel facies, but one of our key insights was that neither method could reliably separate the channel axis from off-axis facies when working within the typical seismic frequencies. So I want to talk really quickly about a common challenge we have in seismic interpretation, because in machine learning, we often default to 256 clusters without really knowing if it's optimal. So here's an example of what happens with SOMs when we use those 256 clusters. So you'll notice that the clusters blend together with similar colors, making it kind of difficult to distinguish between the different channel facies. But check out the GTM results. Here we get much better facies discrimination, with the distinct fuchsia color representing the channel axis and then the orange for off-axis. So despite setting up both methods for 256 clusters, SOM only generated 37 distinct clusters while GTM produced 123. And this tells us that more clusters don't really mean better results. So the key lesson here is that sometimes less is more in machine learning. And if you want to learn more about uncertainty and ML-based seismic interpretation, you could check out our full paper in the Interpretation Journal. So I hope you enjoyed this 2-minute summary of recent AASPI research, and I'll see you next time.